Okay, let's take a closer look at the 68, 95, 99.7 rule. That pretty much tells us everything that we need to know. It's also sometimes referred to as the empirical rule. Okay, so again, as we know, we've got 68% of the data falls within one standard deviation of the mean. 95% of the data falls within two standard deviations of the mean. And finally, 99.7, just about everything falls within three standard deviations of the mean on a normal curve. Okay, so let's take a look at a couple of things that we get to add to this when we know that we've got this normal curve and apply our symmetry. So we know that the median and the mean are the same, or roughly the same, in a symmetric distribution like we have here. So we've got 50% of the data is above and below. If I think about my 68% and I've got 32% above and below, I can split that in half. So I know that those two tails would be 16% each. If I go out another standard deviation to 95, I know that my two tails are half of 5%, or 2.5% each. And last but not least, those little tails there in the end would be about 0.15% each. Okay, so let's go ahead and apply this to a particular problem here. So we actually know some information about the heights of males in the United States. We know that it's roughly normally distributed with a mean of 69 inches and a standard deviation of 2.5 inches. And again, I could write it with this particular notation here. All right, so the question that we're asked is what percent of U.S. males are between 69 and 71.5 inches tall? So let me get a different color pen here. Okay, so what I'm going to do first is, I've already had this pre-drawn here, I'm going to go ahead and label what I've got here. So I know that the center is 69 inches tall. So there's my 69 inches tall. One standard deviation up is going to be 71.5. Two standard deviations up would give me 74. If I went to the other side, which I don't necessarily need to for this problem, I'd get 66.5 inches tall. Let's go one more, 64 inches. Okay. All right, so what are we interested in here? We're interested in heights that are between 69 and 71.5. In other words, those values that are greater than 69 and less than 71.5 inches. In other words, we're looking at this particular region right here. And this picture really helps me see what I'm looking at. Okay, now we can see that this is bordered by the mean and it's bordered by one standard deviation above. So I can go ahead and really jump right to my empirical rule, or my 68% portion of that rule, and say, I know that there's 68% of the data falls within one standard deviation. And what I'm looking for is exactly half of that. So this shaded region that I'm looking for will be 68% divided by 2, again, due to symmetry. It gives me 34%. So approximately 34% of males would fall between 69 inches and 71.5 inches tall. Okay, let's take a look at another problem here. What percentage of U.S. males are less than 64 inches tall? So let me just change this back to a better color here. Okay, so I'm looking for heights less than 64 inches tall. So again, I'm going to start on my normal curve. Whoops, I'm going to start on my normal curve, and I'm going to go ahead, and that doesn't look like a terribly straight line. I know I'm on the downside here, so I'm just going to go ahead and label down below. There's my 64. And I'm interested in those that are below 64. Now, I can see that I'm 2 standard deviations below. And if I think, again, 2 standard deviations, I know that within 2 standard deviations, I have 95% of all of my data. So therefore, the 2 tails must make up the remaining 5%. So what I have over here would be my remaining 5%, but only half of that, which gives me 2.5%. So what percentage of U.S. males are less than 64 inches tall? Approximately 2.5%.